So good morning, or late afternoon, or whatever you think it is, depending on your time zone. I think it was Nicole Harris who said the other day that when you stand up here and look down at the crowd, you feel it's wrong to talk about networking and e-infrastructures. You should be thinking in upper area. But those of you who've had the bad luck of hearing me sing will be relieved to hear that I have enough self-control to not do that at this point. But though impressive as these surroundings are, and we can admire them, I've done so for a couple of days now, I also can't help thinking if there's a lot of history embedded in this place. Lots of things have probably gone on in this room, impressive lectures. I would have liked to be able to hear that. If these walls could talk, they could tell a lot of stories. And in fact, one of the stories they could tell us about was that, 4 years ago, 5 years ago, one of the many European collaboration in the infrastructure, the EGI, was formed here in Uppsala and held one of the very first meeting in this room. And so for this closing plenary, we have decided to invite back to Uppsala the then director of the EGI, Stephen Newhouse, to tell us about his latest adventure. Stephen has been working many years with e-infrastructures and has recently transitioned to working with infrastructures for research, and he will, I think, tell us a little bit about the difference between the two and how the two interact and should be collaborating in Europe. Stephen, apart from having been the director of the EGI, has previously worked for Microsoft with the Windows Servers division. He's been the chair of the Open Grid Forum. He's worked with the UK e-infrastructure program and was technical director of the EGEE collaboration. So lots of history with high-performance computing, grid computing, facilitating e-infrastructures. And Stephen now works for the EMBL EBI, which is one of the large infrastructures for science located in Cambridge, serving all of Europe. So Stephen, please, the floor is yours.
So thank you very much for that kind introduction. And it's actually 4.5 years since I stood on this very place to introduce the European grid infrastructure to the EG3 community. I came to Uppsala for 4 days, and I stayed for 7, courtesy of the volcano that went off that time. So fingers crossed, no volcanoes in the next 3 hours, and we can all get to the airport and get home. So what I wanted to spend some time talking about today is this complex interplay that's developing in Europe between the e-infrastructure provision that we've got, which for 4 years I was part of, and now the research infrastructure provision that we have, in particular in relation to Elixir, the research infrastructure for life science, and how these two can interoperate. So it's always a good idea to start off with some philosophy. Laws are like sausages. It's better not to see them being made. And unfortunately, this is probably also true for infrastructures. Now, infrastructures are great things to use, be it mobile phones, be it Wi-Fi, and so forth. Unfortunately, you don't want to be on the producing end of Wi-Fi infrastructures, to have the wonderful interplay of different devices, different frequencies, different channels, and so forth. So this is where I think we're facing a choice that as how we present ourselves to the research community and try and understand what they want. So what is it what a researcher wants? Well, researchers have been fundamentally described as selfish people. They want to do excellent science, they want to have everything available to them whenever they need it, working the way they want, and they will work with anybody that they can if it means that they can do their work and the ultimate goal, to publish first. Okay? So that is what everything that we do in the infrastructure, be it e-infrastructures, research infrastructures, is just there as a greasing mechanism to enable the researcher to do excellent science. What hopefully they don't want, and this is not true to all researchers in all communities, is to do any of the work, any of the technical work. They don't want to manage the complexity, to run infrastructures 24/7, to deal with the staffing, the redundancy to achieve that, to track down software issues, to a whole range of things that we in these communities do on a regular basis so that our customers can get what they want. So this is really driving a choice not just for us on the infrastructure side, but also on the research side as well. And the best way to illustrate this choice is pizza. Now, I think pizza is something we can all relate to a greater or lesser extent. And pizza, the way it gets into your mouth, has got many different ways of doing it. At one extreme, you can own the whole problem. You deal with sourcing all the ingredients, making sure that you've got somewhere to bake it, all of that infrastructure, including somewhere to eat it and the materials to eat it, if you use a knife and fork when eating pizza. Or you can start outsourcing elements of that. You can get a pizza that's been made up in the supermarket, and you can just put that in the oven, and that saves you the labor of having to source all the individual ingredients themselves and prepare it. You can go higher up the stack in that you can get something delivered, a pizza delivered, and then you don't need to even worry about the baking or the sourcing of the ingredients. You just have to eat it and find somewhere to eat it. Or the final lowest hassle solution is to go somewhere where you're provided with the table, the chair, the knife and fork, if you wish to use it, and you can eat your pizza out in a restaurant. So these 4 solutions have a spectrum of activity. You can go for the very simple, but you own all of the problem, or you can go to the very simple where you don't own any of the problem, and you just go along and you make use of that as a service. Now, these are the sorts of questions I believe researchers and people in research infrastructures should now start asking themselves as they start looking and planning their future infrastructure needs, as to what is it that they need to do themselves and what is it that they can rely on others to do for them. And I think the critical issue around this is, what is the relationship in how the other people do things on your behalf? Is it a traditional academic collaborative model where there's no contractual relationship? Or do we move to a more commercial relationship where service level agreements and metrics are used to drive and to monitor the performance of the service that is offered? Some of those concepts, customer, service level agreement, contracts, are strange words within the research community, but are getting, I think, more and more important in terms of building large-scale collaborative infrastructures. So the questions that I see myself asking and others trying to ask is, what is the boundary between researchers and e-infrastructures, between researchers and research infrastructures, and perhaps more complicatedly here, what is the boundary between research infrastructures and e-infrastructures? Because there's a very blurred area as to who is doing what under what particular hat. And so all of these things need to be established to help understand where the value that people need in order to do their research work is actually emerging, and how that can all be put together in some sort of chain of interactions to build up value so that everybody in that chain is able to contribute the most that they can, and the people above them in that chain are able to benefit from that knowledge and actually build a reliable service and a reliable infrastructure on top of that. So that's what I want to focus on, but I'm going to start off by describing really a bit of the complex landscape that I see we have within the infrastructure world, and then looking to see, take an example of how some of those components can be brought together, and then finally pausing to reflect on some of the areas that I think we can move on in the future. So the landscape that we operate in, certainly that I operate in, is very much based around molecular data, but the data deluge and the data tsunami that many research areas are facing drive through in some of the same challenges. And we're faced with this challenge of moving data through to information, through to knowledge. And that conversion, certainly from data to information, is more and more driven by high scale and high throughput analysis. How can we actually understand from the different genetic sources and molecular sources that we have what individual chemicals are doing, what individual genes are doing, and how they interact on the various pathways through to human health and human behavior. So to do that, to date, EBI, as an example, has been focusing very much on what infrastructure it can put in place internally. But with the rising scale of data, this is an infrastructure that is having to expand dramatically. And both us as an institution and as a community are very keen to explore how we can spread out that burden of infrastructure into other collaborators. So we have a very interesting world in Europe where we have the blessing of e-infrastructures. And we have the blessing of many e-infrastructures in various areas. We have our networking community. Certainly at the moment, we still have 3 logos here. That may obviously change in the next couple of months. We also have a number of data providers as well. EUDAT has reaching the end of its first phase of activities in terms of building a collaborative data infrastructure. And OpenAir is looking very much at data as part of the open data and open science initiatives at the other end of the research process. When it comes to compute, we have plenty to choose from. Prace dealing very much at the high end of supercomputing activities, and EGI at the high throughput end, driven a lot by the high energy physics community over the last 10 years, but now expanding out to support other research communities and their needs as well. EGI has also expanded in the last 3 or 4 years to include cloud activities, and this has come alongside other European cloud initiatives such as Helix Nebula that looks to see how commercial cloud providers can integrate into and meet the needs of large science collaborations in terms of their computing and storage infrastructure. But with every blessing of the infrastructure, there's also a curse. And the curse with the infrastructures in Europe is very much around which ones to use. There are, in a sense, so many sitting in the same space, certainly in cloud and compute, that the choice becomes challenging. This is perhaps simplified if you just think about at a European level, but if you also roll in your national and your local support, it becomes incredibly challenging. If you're a researcher doing a computational problem at your local university, you use one particular system, you get used to that, and then you start reaching the capacity limits of that cluster, and you want to move up to your national resources, or in the case of the Nordics, your regional resources. That's something you can do, but will it be the same interface? Will it be the same environment? Very unlikely. Different levels, different groups make different decisions as to how they're going to operate and manage their infrastructure. And that carries through when you move from out of the national, from the regional, into the European level as well. So this changing of interfaces and also the legacy of interfaces, if you're already supporting a research community, make it quite challenging to be nimble in meeting the needs of new research communities, but also in terms of evolving your service. And then you have a choice as to the sort of the partnership model that's available to you. Many research activities have a multi-decade long planning cycle. We think internally about what we're going to be doing in 5, 10, even 20 years in terms of our infrastructure needs. As a legal entity with a strong European-wide backing, this is something that we're able to do. If you're a 2-year or a 3-year EC-funded project, what measure of confidence can you give to a research community or a research infrastructure to start adopting and using your software and the services that you're providing? The issue around the trade-off between projects and organizations to contribute to sustainability is something that was explored within the EG series of projects, and particularly within EG3, and that led to the creation of EGI, based very much upon the network model, the NREN model that has been surviving in existence for 15, 20 years plus. But is this something that EUDAT is going to focus on and do? Is it necessary for EUDAT to build on that model? Helix Nebula, taking a different approach for its commercial operations, means that if there's a need for the use of that service, people will pay for it, and if they're paying a proper commercial price, then that service will carry on being sustainable because of the use that it's able to generate. But what are the ones that you can actually rely on in this, and what are the means that you have to actually ensure that that service is going to be there both now and in the future? And contracts provide one area of doing that. But this is just focusing on the e-infrastructures, which is really the very bottom layer, the foundation layer, in terms of interaction between the scientist. And so on top of the e-infrastructures, the very generic e-infrastructures, you see many sort of community support and community infrastructure models being built. Within life science, this is perhaps typified by Embol EBI, the organization that I'm part of, that very much looks down into the infrastructure level and providing a set of services that are usable up towards the end scientist. Elixir, which is this new research infrastructure that's been established since December last year as a result of a 6 or 7 year long preparatory phase, does a lot more outward-looking community support, understanding the requirements for standards within the community-defined metadata. What are the issues around ethics that need to be handled? What are the common storage and cloud requirements? These are things that are there for the community as a whole to come together to provide services then that are able particular research domains to work on there. And so within the biomedical science area of S3s, there's a whole range of different research infrastructures, and I've only put 4 up on the slide. But these provide specific support for particular communities in what they do, and those are something that we need to understand what those particular requirements are and how they interact and impose things on both Elixir and on the e-infrastructure underneath. Excuse me a moment. So we then, with that domain support, then start going into sort of 2 different areas. Because support can be focused around particular disciplines, but support can also be focused around national activities. NAIC at a regional level within in the Nordics, but also then your own individual e-infrastructure support, which may also have a component of life science support within it, and also perhaps specific bioinformatics activities at a national level that can provide specific domain support. So you can already see when you start getting into a national level that there's support that on both the technical, on the e-infrastructure side, and also on the scientific side as well. And then finally you go up to the localist level, the local support, where you actually are able to, a researcher is actually able to go and sort of talk to somebody over tea or coffee and actually explain their problem face to face and try and get some support around their particular problems. This is perhaps the least tapped on area of support that we have available. And part of the reason I feel for this is that many of the services lower down in the stack have been so complex and so changing that it only are people that are very near to the problem that are able to explain what it is that's going on. One of the advantages of the move towards virtualization and the commoditization of services such as cloud and storage mechanisms like Dropbox and Box, and the whole spread of Google Apps and web-based services, is that those are much more commonplace. They're also driven by support and use across communities other than just science, that it's much more likely that people locally are able to help you with those problems because these solutions are much better known and much broadly available. So looking at one aspect of this, which is community support, I'm going to pick on EMBL EBI, an organization I'm beginning to know quite well. So EBI's mission within life science is to provide freely available data and bioinformatics services around that to a whole range of scientific communities, both those clearly within life science and also outside of that. We're based on the campus in Hinxton, the Wellcome Trust campus there, alongside the Sanger Centre, and we've been building out the infrastructure we have there, both in terms of the service teams that put together our services and curate the data, but also the technical infrastructure that supports that work. So as an organization, we provide services and data resources. So these data resources are not data that we generate locally. This is data that's contributed to our archives from all over the world, primarily Europe, but all over the world. And these can be data that's contributed publicly. We have an increasing body of data that we call managed access, and this relates to data that's collected around medical trials and medical experiments, where people have their whole genome sequenced, and that's attached also to a set of medical information relating to the diseases or the background of that individual. And this starts to provide very important information trying to relate what the sequence might look like, what the genetic information might look like, and what impact that has on the person's health or characteristics. Now, clearly that's quite personal information, so access to that is managed through organizations external to EBI. We're just the custodians of the data in that case. But this infrastructure, both the public and the managed part, allows individual sequences or whole studies to be downloaded and made available for researchers in their own institute. So to support that work, we provide access to a set of common tools through both a web interface, a human web interface, and also a command line programmatic interface. And this effectively allows us to do analysis on behalf of researchers using our particular services. But that is quite limited in terms of what we can do. It depends on us having the tools integrated into our infrastructure and the person being able to access those and understand the complexities of running and submitting their jobs on our hardware. Part of the challenge that with this particular mode of operation is that the data that we're storing is doubling every year. And so previously, when a researcher was not able to run the types of jobs, do the types of analysis through our defined tools, they would download the data to their own institution, set up the services they need, and do that analysis locally. The fact that the data is doubling every year would mean that their local infrastructure would have to be doubling every year. And that would clearly provide them with some challenges in terms of how they establish that. So just to put this data growth into context, we have here a set of various graphs on some of our different archives, the medical details of which I will not cover. But you can see there are some The biggest archive is doubling every 12 months. Some of the smaller archives are doubling every 3 months, but luckily from a much lower base. So this drives a very strong demand on our infrastructure in terms of what support it can actually provide. We're very fortunate at EBI to be the recipient of a very large Capital Facilities Award by the UK government. And this is enabling us to provide a lot of the computational and storage infrastructure that we have at the moment. But just to put that into context, this is a look forward for the next 6 years, the remaining term of that particular funding stream. And you can see that our annual investment on infrastructure, on just the compute part, the compute and storage part, is moving from about £4.5 million a year to £9 million a year. And this encompasses the doubling of the data each year, but also considers the improvement in storage density, in the electrical cost around that storage, and other technical advances that, statistically we can sort of predict where that is. But that brings us in 2020 to having a storage requirement of about 2 exabytes and 250,000 cores of data. That would be a fairly good Amazon, Microsoft type data center at the moment. So clearly in 4 or 5 years' time, they will advance, but that's the sort of infrastructure that we see us having to have access to in 5 years. And so clearly, in terms of strategic planning, how to provide that infrastructure is one of the things that's driving a lot of my thinking, a lot of the leadership, both at EBI and also within Elixir, to see what sort of solutions as a research infrastructure can Elixir as a community provide across Europe to solve some of these things. So just as an illustration, I lead a group within EBI that focuses on providing a platform to enable all this. So not only the physical infrastructure in terms of the data center space and running the services around that, but also to act as to provide a platform to our internal teams so they can develop services, host databases, and focus a lot more on the science that they do rather than dealing with some of the technical infrastructure. So this is a very good first example of the pizza analogy. Okay, so if you recall back into that pizza model, the first vertical slice of pizza was around everybody managing their own. And historically within EBI, the different service teams would have their own hardware, their own systems administrators, their own database administrators, operate their own web services to deliver their services out to their research communities. Over the last 5 years, I would argue that we've professionalized what we do, and we now have dedicated teams that run the storage and the compute for the whole institution, rather than those working on individual groups. The database teams the database administrators are now hosted centrally, and there's a central team that provides databases back out into the individual service teams to support their needs, and likewise with the web services as well. So we've moved as an institute from doing everything in the service teams in terms of building pizzas to much more towards the right, where we've been able to build trust and understanding and have an agreement as to what the services are going to be delivered so they can be provided centrally. This was not easy, but it illustrates that you can build trust and do this at a local level. Can you build trust and do this at a national and a European level as well? So if you look at what use EBI makes of e-infrastructures, networking at the moment is our greatest benefit. The data centers we have in London have large 10 gig pipes that plug into Janet, the UK NREN, and through that we're very closely linked to the Géant in terms of its international links, and this provides an excellent feeder both for the traffic coming into EBI and also the traffic going back out into the research community. EMBL, which is the parent organization of EBI in Heidelberg, has been working with the Helix Nebula initiative to see how commercial cloud resources can be used to support various components of some of our analysis workflows. And that's provided a lot of useful insight into the strengths and also weaknesses of commercial cloud model, but also to help drive the understanding as to what a commercial cloud provider would need to do to be useful for research. And we have ongoing pilots looking at how we can use EGI, in particular some of its cloud work, and also EUDAT in terms of the software activity of moving data out of different repositories from one to another. So that's what we're doing. It's a very community level at EBI. Above us, in some sense, is Elixir. EMBL EBI is one node within the Elixir Federation of nodes. Elixir is looking at a much broader agenda in terms of the building a community of services, tools and standards and training around life sciences to cover all forms of it, both human medicine, but also agriculture and the environment as well. Elixir is getting growing national sign-up. The number of countries that have signed the MOU, which is the sort of preparatory phase, was already very large, and those who have now converted their MOU status through to being members of the legal organization is increasing every couple of months. And I think I won't put a figure as to how many it is now, because I'm sure I'm going to get it wrong and I won't risk doing that. But you can see the sort of the range of topics that Elixir is focusing on. These are both the technical side in terms of services, tools, and how to deal with data, but also the standards side in terms of how can we have consistent bits of metadata coming from different sources that enable that data to be reused and picked up by different research communities. And also to make sure that the scientists, increasingly the data scientists, have got the right set of skills and the right set of services are available for them to use that. So I'm going to focus just on one particular area of Elixir in terms of seeing what it's doing, which is around the technical services. These are perhaps most relevant to the what impact e-infrastructures can have within this. So one of the greatest things that has come out of e-infrastructures, perhaps that we've not yet perhaps had the biggest impact of, is federated identity. Certainly Elixir is making a strong, commitment and also active involvement in trying to drive through some of the federated identity mechanisms that can be used not only for group management, so how to manage collaborations using federated identities, but also using federated identities as a route to dealing with some of the data that we have that is restricted in terms of who can access it. And there's been a very strong pilot being led by CSC and EBI to explore how federated identities can be used to manage the workflow in terms of the approval release around getting access to sensitive data sets. So recent work by the storage task force has not surprisingly shown that there's a very heterogeneous set of storage principles and practices that are used across the community. There's ongoing work to see again how EUDAT and EGI can work and can contribute to this sort of activity, and also not only looking up to see what the capabilities by the underlying storage provided by the e-infrastructures are, but also looking up to see what some of the requirements are coming down from some of the other more science-orientated research infrastructures within the biomedical space. But what's interesting about this, both here and also in the cloud, is that it's not immediately obvious that the solutions that are available from the e-infrastructures are the ones that are needed or desired by these communities. So in a sense, there's a failure of marketing or a failure of description or a failure of communication from some of the e-infrastructures to do this. Now, I can hold my hand up for this for a couple of years. Now, a lot of this is the complexity in actually understanding what are the requirements coming from the science communities around this. And this is where, again, trying to understand whether should e-infrastructures engage with research infrastructures or should they engage with the individual researchers in driving requirements, I think is something else that we need to address in this. This is also, when you look at the cloud activities, members of the Cloud Task Force have engaged in the EGI Engage proposal that was submitted a couple of weeks ago in terms of establishing a competence center. We're looking at the EGI federated cloud model to see if this is one that makes sense for us for the requirements we have emerging out of Elixir. But likewise, we're also discussing what some of the cloud requirements are from some of the research infrastructures that are sitting more closer to the scientists as well. So this shows again, what is the relationship between Elixir and e-infrastructures. So perhaps one of the things that we haven't yet tapped on, because we haven't yet moved into that sort of operational phase of Elixir, is being able to leverage existing national support structures. So if you take PRACE, EGI, GEONT, there's representations of those organizations and those activities in every country across Europe. This makes support a lot easier if you are able to leverage it, because there are people that people can travel to, by train, maybe in their own institute, that they meet at national conferences, so they're able to benefit from a whole pool of knowledge that already exists locally, rather than feeling they have to come to a top-level European meeting in order to understand what the particular problem is. At a European level, Elixir's endorsed the GEONT Code of Conduct as a mechanism to help build confidence in the service providers that are using federated identity, and has been working to align some of the requirements within the community to define use cases that can be passed on to infrastructures to help drive some of their development. And likewise, there's also the use of exploring some of the other infrastructures that already exist that are out there. So in terms of the aligning requirements and use cases, one example that's been running now for nearly a year is those around Enlighten Your Research. And I think this has been talked about elsewhere within the meeting. So this has been very much a GEONT project-initiated activity with some funding. A lot of that funding has been going into this particular example into the Netherlands and Finland, with a small portion coming to EBI in the UK. And the use case here is to see how can I take an analysis that I want to do and move the data to the available cloud resources, move my virtual machines to where the cloud resources are available, and then somehow instantiate that analysis. To do that in real time, or to do that immediately, you want to have some confidence as to the ability to transfer both the data and the virtual machines. And this is where the GEONT and its bandwidth on demand activities have been helpful in trying to work this out. So certainly there's been work going on within the Netherlands to set up this sort of bandwidth on demand locally within SurfNet. There's links now set up with CSC in Finland, both as supercomputing provider and as the NREN. And moving across into the UK, this has been one of the first things that we found was that this bandwidth on demand concept, this service, is not one that Janet in the UK sees there's a need to support. Their argument is, quite rightly, that there's a lot of backbone capacity in the network already. So what is the requirement? What is the user requirement for additional bandwidth at a 1 gigabit level for a light path when you've already got a large 40 gigabit plus backbone already available to you. So this is an interesting response from an NREN, and certainly I think that the status at the moment is these sorts of experiments are proceeding, and we're trying to understand what is the actual operational capacity in moving data around from elsewhere across Europe into the UK data centers to see if we actually need dedicated bandwidth provision, or whether the capacity that already exists within the internet provision within Janet is sufficient for that sort of data movement. So above these sorts of community support through that EBI and Elixir provide into the life sciences, we then have a much broader activity through Biomed Bridges. Biomed Bridges, as you see, brings together over 10 additional biomedical area research infrastructures together. Each one of these have got their own focus on a particular area of life sciences activity, be it biobanks, be it images, analysis, and so forth. Okay. So what is the role of these activities alongside more generic activities such as Elixir or even EBI in some ways? So this illustration, I think, difference in role between domain and community research infrastructures. So the life sciences area is perhaps unique in having Elixir as a sort of a spanning research infrastructure that other research infrastructures build upon. Other domains such as the physical sciences and environment see perhaps much more building on top of the e-infrastructures directly. But the domain research infrastructures sit much closer to the scientist, and I think this is one of the key values that this whole Elixir and domain research infrastructure provides. And I compare it to the high-energy physics experiment, one of the high-energy physics experiments, CMS. Each of these domain research infrastructures represents the interests of hundreds or thousands of individual scientists. And they're a much tighter set of use cases and requirements than if you were to consider the whole of the, say, 2 million life science community activities, 2 million researchers in the life science community more generally within Europe. So they're able to provide much more focused use cases to help drive developments, and they're also able to sit much closer to the researchers in understanding what their needs are. And if you then look at the community research infrastructure, such as Elixir, again, they are there to actually understand much better the connectivity with the various research infrastructures that sit on top of them, and are then able to speak with a much stronger voice to e-infrastructures in terms of how to manage the complexity that they provide. And so you can see a similar sort of relationship between the BBMRIs, the Eurobio imaging with Elixir, that you see between CMS, Atlas, and the other HEP experiments as they feed through into WLCG, and how the success that WLCG has had over the last 15 years of influencing the way e-infrastructures have been provided. I think the opportunity is there for Elixir over the next decade to do the similar sort of thing for the life sciences community. But this then brings up I think another question for the e-infrastructure community, is what is their mode of operation? Are they operating in a business-to-business model, where the e-infrastructure talks to a small number of national domain service providers, and it is the national or domain service provider that holds the relationship with the researcher, the active researcher? Or does the e-infrastructure provider try and skip the national domain service provider and act as a service provider directly to that researcher, to enter into a business-to-consumer role around that? This is quite a challenging thing to do. You're moving from one e-infrastructure to support potentially 20, 30, 40, 50, 100,000 different users. Is that something you're actually capable of doing? I think the answer there has to be questioned. Because this is the thing, is that the users of e-infrastructure, very few of these are actually researchers directly. Even in the best example of high-energy physics, most of the high-energy physics researchers do not use e-infrastructures. They use the experiment environments, the web-based environments, the analysis engines that are provided online to submit and to pose their particular problems. It is the team at CERN, in the case of WLCG, that supports those applications, those tools, and liaises with the relevant e-infrastructure components to make sure that the operation delivery of those takes place. So this provides very much a more of a business-to-business model. At the moment, though, that is set up in a very collaborative mode. And I think one of the challenges of people who already have infrastructure and they're asked to try and adopt e-infrastructures is to get a much clearer understanding of what the business model is. Are there service level agreements? Is there somebody there, an account manager, that you can phone up and politely shout at if something isn't going well? Are there regular consultations to understand what your evolving needs are as an organization to help drive future planning so that the capacity or the service that you want is ready when you need it? And so really are many of the service providers that occupy this middle layer in the national domain area actually set up for this business to consumer role? This whole business of service management, if you go as far as formally as ITIL and other models, or are you operating again back at the collaborative research mode where everything is best effort? Best effort is great if you're operating at the research level. If you're trying to build infrastructure, you really want to build up a more coherence and more confidence in that than just best effort. So let's look at this as an example around personalized medicine. This is a fascinating area in terms of the, let's call it the inaccuracy of modern medicine. So here are some statistics as to how effective or how ineffective various drugs are. Okay, so I don't want to worry you, but when you go into your doctors and say, I have this problem, say, sure, here are some pills to solve it. In some cases, those have got a very high confidence that that's going to solve the problem. As you move to perhaps rarer diseases, the understanding of those diseases is much less known, and so the effectiveness of some of these drugs has also decreased. So around this, there's now the scope to do a lot more personalized medicine in terms of whole human genome scanning. This is now reduced dramatically in costs, where it takes a couple of days, a couple of £1,000, dollars, pick your currency, compared to the decades and the billions that it cost 15 years ago. So this provides a whole new way that clinicians can work with this data and start driving the analysis. The UK is looking at scanning 100,000 genomes across rare diseases over the next couple of years, and there's similar initiatives taking place all over Europe, and where these genomes will be linked in some form or in summarized form to the individual's medical records. This allows the collection of knowledge about one patient's data, the data that a particular doctor is looking at, across all of the other patients' data, providing issues around data privacy can be dealt with. So this drives a massive opportunity in terms of saving costs, in terms of our national health infrastructures, and making medicines a lot more targeted and much better effective at improving people's life. To do this, though, needs quite a sophisticated technical landscape. It needs a data infrastructure that's able to deal with the generation of data from thousands of different places across Europe. Unlike CERN, there's not a single collider. There's a whole range of different data sources that are coming together, and that is very sensitive. Also, when it comes to analyzing that, how is that done? Do you keep the data in situ, or do you move it into a secure, neutral third party to do that analysis? And how can you bring expertise across in different areas together? Now, this is one of the, in a sense, fundamental questions that's driving some of the thinking within Elixir. The current model is where all of the data comes into a central area, and that analysis and aggregation takes place there. A alternative model would be to look at a more federated aspect, but then that would mean that the individual data centers outside, the non-central data center would have to store more of that data locally, and that would reduce some of the burden on the services, the storage that has to be done centrally, and push some of that burden outwards. So this sort of trade-off between data is one of the things that's been driving some of the thinking within EBI, about how can you make the data analysis much more flexible to individual research communities. I mentioned earlier about the challenge that large data is bringing, and this has triggered us within EBI for a couple of years to start looking at how researchers can bring their analysis to a secure cloud environment where they can operate close to EBI's data sets rather than having to download those data sets onto their own local infrastructure. This has been done through the EBI's Embassy Cloud initiative. The embassy model, driven from this political world where an embassy is seen as sovereign territory, owned by the tenants that the host country isn't allowed into and doesn't have any legal jurisdiction over. And this has been a model that we've been using over the last couple of years to build up a very interesting user base around this. The Embassy Cloud of an EBI is hosted in our data center, and so we're able to provide quick access to the data that we have and also the services without having to go back over the open internet to do so. And this also gives some of our collaborators and some of our commercial customers much more confidence in using that infrastructure if it was hosted in a third-party data center, wherever that might be located, either in the UK, Europe, or internationally. So the Embassy Cloud concept allows a whole range of different tenants able to access both our public services, our public data, and our managed data in a very quick and easy way. And this is something that's being used within the pan-cancer analysis, is a global collaboration to understand some of the analysis work coming out of whole scans of some of these cancer genomes that are now being collected and contributed into this study. So where do we go in the future, recognizing that I need to move up, finish in the next couple of minutes? So in terms of future directions, Elixir is presenting, I think, going to be presenting a whole series of challenges to the e-infrastructures. So federated storage infrastructures, these are things that have been looked at, and the model at CERN of having a central data store that's then distributed has shown to be work operationally, but that's where you've got the data being produced in one place. In Elixir, most of that data production, all of that data production is distributed across Europe. So perhaps more of that data needs to stay where it is generated, and just the processed results should be stored centrally. But that raw data, that locally held raw data, needs to be available if people want to go and get back to the original source. So this poses a lot of interesting challenges in terms of who has access to that raw data. Can it move outside of that institute? Can it move outside of that country? How long should it be left for? How long should it be retained? And so forth. The federated cloud work that's being discussed within Elixir is also going to pose some challenges. The idea of having a catalog of virtual machine images that are available for community use is excellent, and there's infrastructure from EGI to help doing that. But the support, as we've seen, for pushing virtual machines to where the data is located and so forth is not quite as mature, and has to cope with that. Might be in an institutional cloud, it might be in a public cloud, or it might be in a commercial cloud as well. And the federated identity challenges we see as being driven much more by policy issues rather than technology issues, which in a sense is good. You know, if all our problems were policy issues, that might be a lot more solvable, but we still have most areas, some technology issues to deal with as well. So what lessons can we learn? And I go back to my good friends in the high energy physics community. 15 to 20 years ago, the high energy physics community defined a problem sufficiently important and sufficiently interesting that they managed to motivate the world to build them a grid, and they managed to motivate the world to pay for it. And I think that's done very much through the very strong representation that the physics community were able to provide centrally, and that physics community were able to drive through into their own national structures. Elixir is now, I believe, very much at the beginning of that opportunity. It's got been prioritized through the S3 process. It's got 10 experiments, effectively, as opposed to just 4 to drive things through, and is at the moment identifying a technical infrastructure to help meet those needs. So going back to the pizza model, and what can we learn from this as we start planning Elixir? For AAI, I asked the question, does anyone want to actually own this? You know, the networking community have done a great thing in terms of providing basic identity, but on top of that, there's a need for much more group management and authorization to build into the workflows. In terms of storage for a community where at the moment our storage is 47 petabytes at EBI, and as a community might scale up to a couple of exabytes over the next 5 years. What are the storage infrastructures available to scale up to that sort of model and do that in a distributed manner? I don't believe they are there. Grid FTP and Globus Online we found locally at EBI to be a very good consumer solution. You know, that's a set of problems we don't have to own. We can work with others in terms of delivering us a service to that. But obviously all of that data transfer is underpinned by good European networking connections. And then in terms of more pizza-related analogy, you know, the cloud is a very rich area for development. There's many, I call inconsistent with each other, working solutions, which is good. The richness is nice, but that diversity also leads to complexity, it leads to uncertainty, and so more structure at the E-infrastructure level around clouds, I think would seen as a great benefit in simplifying what it is that other research communities could use. And this is something they're also looking at more locally at EBI. So if you look at the future infrastructure, focusing on Elixir, you can see a whole range of both commercial and community-based cloud providers, both at, say, EBI or out in the nodes across Elixir, either providing just data or providing data and compute analysis. These can be used to provide a public service by pushing out virtual machines from a central source and their supporting data sets onto that infrastructure. But it also can be used by private analysis by research groups gaining hold of their virtualized resources and doing their own analysis on top of it. What's missing, clearly, is an integrating platform to bring that all together, and that's something I hope the Elixir community, in conjunction with other communities, science communities, and the E-infrastructures, can work on over the next 5 years. Thank you very much.
Thanks a lot, Stephen. You've solved a very important problem for me here today. Next time I go to a family event and my aunt asks me, what is it actually you're doing? I can just tell her I run a pizza parlor.
There you go.
So that's very nice. So we have time for a few questions for Stephen. And I can't see anything, so I can't see if there are questions. Yeah. Inda? Oops.
A very nice talk, thank you. Obviously, I'm from the networking area, so I'm going to ask you a question related to that. In the problem of data movement, either people moving data to you or outside from you, either into a cloud or their own storage infrastructure, where in your opinion, is the bottleneck? Is it the wide area bandwidth? Is it the storage I/O? Is it the compute systems dedicated to move data? Where do you think is the bottleneck that needs to be addressed?
Yeah. So I don't at the moment think it's the network. Okay, certainly not the European network or our local UK network. We're doing some experiments at the moment, very, very slow progress, in terms of seeing how quickly we can stream data from EBI out over the 100 gig link that's been in existence out into NCBI in the US and potentially Indiana, both Chicago and the Indiana University. So that's helping us to try and get an understanding as to whether we have blockages in our own storage infrastructure. I think a lot of it is bluntly at the client side, at the remote sites. For the major service providers, getting a light path, having 10 gig connectivity or so forth into their NREN point of presence is not an issue. But for many institutes, the smaller institutes, the available networking bandwidth drops off quite quickly as soon as you start getting much nearer to the person's desktop or their cluster. So I think that's where the area is probably going to need the most investment, but clearly that's the area where certainly from an EBI perspective, we have absolutely no control over.
And can I ask a follow-up? Is there any data security, privacy concerns? I mean, I think you hinted that, but I just want to know that restricts the movement of data from either a policy perspective, firewall perspective, or some kind of a AAI perspective.
Yeah, so the short answer is yes. So there's two types of data. There's the public data where we just don't care where it goes. Commercial use is great, research use is great. The managed data is much more strictly handled. People need to go through get authorized by an external data access committee. That's usually based around a research proposal around why they need the data, credibility of the principal investigator and the research community, etc. And then when that data is released, that data is released encrypted to a key delivered separately to that researcher, okay? And obviously there's a briefing around that as to how that data should be managed in the local institute. One of the other reasons we looked at the embassy cloud model is effectively we could deliver that data to that researcher's virtual machine sitting in our cloud infrastructure. We would still have no access to it, but that data would not be sitting on a laptop that could be left on a train. It would be actually sitting on a server in a secure tier 3 data center, and if the researcher kept that data there, one of those risks around data loss would be eliminated.
Thank you.
More questions? Does not look like that's the case. Okay. Thank you very much, Stephen.
Thank you.
So with that, we are nearing the end of our program. We have a few more things to do. So the very first NodeUnit conference was held not very far from here, a little to the north of here, all the way back in 1980. So that's 34 years ago. It's a little hard to think of it in this. We're used to thinking about networking and internet as being very new, but some of you weren't even born at the first conference. So we have some tradition and some history already. Of course, as we heard during the gala dinner last night from Carl von Linne, we don't have the kind of history this place has. We have a slide that won't come up. There's only 400 of them, so it's not a big problem. Can you try it again? Yeah. There we go. Right, No, it doesn't want to come up. Anyway, I can probably make do without that slide. So here we go. So as we heard from Carl Fremlin yesterday, this place has a lot of history. In fact, it has far more history than goes back to the start of this university. I don't know if any of you have noticed, there's a couple of stones standing on the lawn when you walk down towards the church here. And those are actually original rune stones from the Viking Age. So they're 1,000 years old, telling us about that this place has lots and lots of history. And I took a picture of this one that we might get up at some point. I like that one in particular because the text on it starts with saying that Vikmundur let carve this stone in memory of himself, the greatest man, which of course tells me that, we have all these branding experts today, but they don't hold anything on the Vikings. Everybody knew how to do it even back then. I think I've had a great conference. I've heard a lot of exciting things, good talks, had new input, had great discussions in the hallways. I heard from Torben Bach-Petersen early on about the big data. I learned that apparently just by watching my power consumption, people can tell which TV shows I'm watching. And I learned that if my bag gets lost when I'm traveling home from Stockholm or airport today, I can just call any security agency because they will be able to track every piece of baggage everywhere, even if I don't know where it is. And I also heard a talk from Leif Johansson from SUNET, who's trying to do something about these privacy issues that come with all this technology and trying to figure ways to use encryption to really, help us preserve a little bit of our privacy in this world. I heard a talk from Renee about the challenges, I think, in part of making sure we are solving the right problem and spending our money where we are really adding value to our communities. There's a lot of great presentations on global strategy and the importance of that, of global infrastructures. And I heard about the future of the Nordic NRENs and other NRENs, what their role is, how it's changing. And I think I heard a very strong plea from Dave Lambert to remember that even as working together, being a community is important, it is also important to remember that we should cherish the disruptive innovations that come from the few that dare to step out of line and do something new, and we should see that not as a threat, but as a great advantage for all of us and be prepared to reap the benefits collectively of those disruptive changes they cause. I also heard plenty of exciting technical stuff, optical networking stuff, how networking is becoming software-defined, video talks, and all these kind of things that we come here to do. And most of all, I think, I heard about the great importance of us working together, collaborating, working together as teams. And this is becoming increasingly important now that we have all these changes in Europe. We're changing how things are organized, and we're changing how Europe is structuring the networking infrastructures that we just heard about from Stephen. And so this is where I would have liked to have the slide, but I will just say to you, I'll remind you that soon the call for papers will come out for next year's Terina call for papers. The Terina Networking Conference will be somewhere south of here. I think it's even south of Malmo. Lisbon, I think the place is called. In early June next year. Think about submitting a paper, think about coming there, working with all the European community in advancing the state of research networking. With that, I'd like to thank you all for being here. You make the conference, not us. You are the conference. You are what it's all about. It's your collaborations, it's your contribution that make this worthwhile. Thank you very much for being here. And that also goes for the latest figures is about 1,000 unique viewers who saw this, a part of it, remotely. And not just for 5 seconds. What I hear is that the average length of a unique view is 6 hours. So we've been streaming about 6,000 hours of video from this place. I think that's quite impressive. It tells us how also the remote outreach and the use of the network is growing important in that area. We had 5 continents following the conference. Before we stop, I'd just briefly say that much that we at Nordnet like to be about tradition, about our history, and about the things we've always done because we know they work. We also like to be dynamic and disruptive and innovative. René told you about that in one perspective at the start of the conference. Another perspective of that is that we are also looking at the way you guys use the conference and what we think you need for it. And we've been observing lately, the last couple of conferences, that more and more people are coming here to have their own meetings, to have site meetings. There were meetings all day Monday. Some of them were Nordic, there were video stuff. Some of them were completely global, had people from all over the world, from Japan, from Korea, from anywhere. And some of them were very small meetings of just 4, 5, 6 people who wanted to come together and meet and have their own private thing. So more and more we are really becoming the Nordic meeting place, and we want to work with that theme. So maybe look for the conference to change, tell us about how you'd like to see it change. Maybe we will have fewer sessions, more room for site meetings next time, enable you to be the conference and not us to just be talking to you. So we will be dynamic already. Same time slot, second half September next year, there will be the Nordnet Technical Workshop again, where we will try some of these alternative conference formats and workshop formats and for at least for the technical people to come together and share in new ways. So come to that, join us, try out new formats, innovate the conference with us. With that, I think it's very important that the Nordnet conference, all the way since 1980, has always been the work of the local NREN who organizes it. It has the Nordnet brand on it, just like Vigmund had his brand on his stone out here. But the stone was carved by somebody whose name is lost, but we don't want to get lost the fact that it is always the Nordic NRENs who are Nordnet, who do Nordnet, also when it comes to the conference. So without the great work of the local organizer, the local host, there is nothing. So for that, I want to very much thank, and I want you to join me in thanking Maria Hell and all of her team at SUNET for putting together this great conference and organizing this great venue for us. Thank you very much. And with that, I would like to ask Maria to come up here and, so to speak, pass the baton on to the next organizer and for them to meet the challenge of, we've raised the bar here and so we'll have to see what happens next time.
This is an important tradition, I've heard. Anyway, it's been a great week, don't you think? I really think so. It's been very, very good to be here. I mean, many good meetings, of course, and very interesting discussions, and so many good speakers during these 3 days. And also all this networking. And as Lars said, it's also an important time for us to come together and have chats with each other and maybe some private side meetings and so on. But now it's time for me, from SUNET, to handle this important task over to FUNET. There you go. So I am very much looking forward to come to you in a couple of years. I think it's going to be great. I know we're going to do a great job, of course. The only thing I think might be a little bit hard for you is actually beat this auditorium. Good luck with that. Thank you.
Thank you, Maria. Okay, I'm not going to steal very much of your time. I think it's 3 minutes, and I'm going to use this as wise as I can. So I warmly welcome you all to the next Nordnet conference in Finland, 2016. Well, unfortunately, I don't have any details yet, so I don't know where exactly in Finland the conference will be. We'll find out. Last night on gala dinner, I had a lot of discussions and a lot of new ideas coming from you. Thank you for these ideas, and we will then pick up the most suitable and most wonderful option and let you know as soon as we know. Okay, 3 minutes starts now, and as Lars promised that he is not going to sing, I'm not going to sing, don't worry, but I didn't promise that I'm not going to play, so let's go for it. That was for the first minute, and now 2 minutes for the video. And the funny thing is that we made this video a couple of years ago already, but I'm going to reuse it. Let's see it.
Funet-tietoliikenneverkon päivitys teki mahdolliseksi joustavat ja edulliset suurtehoyhteydet eli valopolut. Juha kertoo nyt meille, mitä nämä valopolut oikein on.
Valopolut ovat yksityisiä, huippunopeita tietoliikenneyhteyksiä, jotka toteutetaan optisella kuidulla. Valopolun käyttäjällä on sen tiedonsiirtokapasiteetti kokonaan käytössään. Valopolkuyhteys voi vastata nopeudeltaan tuhansia tai kymmeniä tuhansia kotitalouksien nykyisin käyttämiä laajakaistayhteyksiä.
Nopeuden lisäksi valopolku on myös hyvin tietoturvallinen. Muut verkon käyttäjät eivät voi häiritä yhteyksiä toisin kuin internetissä. No kerro vielä, että miten tämä valopolku käytännössä oikein toteutetaan?
Valopolun käytännön toteutus alkaa asiakkaan yhteydenotosta oman organisaationsa verkkoylläpitoon tai suoraan Funettiin. Toteutus tapahtuu yhteistyössä. Samalla tekniikka tulee tutuksi ylläpitäjille.
No kerrohan sitten, että mihin tätä valopolkua oikein voidaan käyttää?
Valopolun päätepisteenä voivat olla vaikkapa tutkijaryhmät tai korkeakoulujen toimipisteet. Valopolun avulla voidaan yhdistää paljon tietoa tuottava tutkimuslaite muualla sijaitsevaan data- tai laskentakeskukseen. Grid-hankkeet ja laskennallisen tieteen tutkimusprojektit ovat valopolkujen suurkäyttäjiä. Valopolkuja voidaan toteuttaa myös maailmanlaajuisesti yhteistyössä kansainvälisten tutkimusverkkojen kanssa. Täällä Suomessa esimerkiksi humanistinen ammattikorkeakoulu yhdisti eri paikkakuntien toimipisteet valopolulla. Toimipisteet ovat tämän jälkeen kuin samassa lähiverkossa.
Thank you.
Thanks a lot. Great to see that Funet already has taken it up on this thing of being disruptive and having innovative ideas about the conference. And obviously you can expect some new requirements in the call for presentations for next time. With that, thanks a lot for coming. Thanks a lot for being here. Susanna and her wonderful team have organized that there is a lunch for those of you who have time outside. Otherwise, safe travel back. See you next time.